Imagine waking up tomorrow morning and realizing the sun isn't moving across the sky. Your coffee cup sits perfectly still on the table, but something feels terrifyingly wrong. The birds have gone silent, and an eerie stillness hangs in the air. What you don't know yet is that Earth has just stopped spinning and you have minutes, maybe hours, before everything you know ceases to exist. This isn't science fiction. This is what would actually happen if our planet's rotation suddenly came to a halt, and the reality is far more catastrophic than any disaster movie could ever portray. Before we dive into this nightmare scenario, let me ask you something. Right now, as you're watching this video, you're traveling at over 1,000 miles per hour. You don't feel it because everything around you is moving at the same speed, but Earth's rotation is constantly hurling you through space faster than a jet plane. So what happens when that incredible force suddenly stops but you don't? The first thing you need to understand is that if Earth stopped spinning instantly, the laws of physics would become your worst enemy. Everything on the surface would continue moving at that 1,000-mile-per-hour speed due to inertia. Picture yourself sitting in a car that suddenly slams into a brick wall. Your body keeps moving forward even though the car stops. Now imagine that same principle, but instead of traveling 30 miles per hour, you're traveling at supersonic speed, and instead of a seatbelt, there's nothing to stop you. Every person, every animal, every building, every ocean, every grain of sand would become a projectile traveling eastward at devastating speed. The atmosphere itself would keep moving, creating winds beyond anything ever recorded in human history. We're talking about hurricane-force winds that would make Category 5 storms look like gentle breezes. These apocalyptic windstorms would strip the surface of everything loose, turning ordinary objects into deadly missiles. But the horror doesn't end with being flung across the landscape. The oceans, containing billions of tons of water, would also obey the same laws of physics. Massive walls of water would surge across continents, creating tsunamis that would make the 2004 Indian Ocean disaster look like a minor splash. These water walls would be miles high and would travel at the speed of jet aircraft, obliterating everything in their path. Coastal cities would disappear in minutes, but the destruction wouldn't stop there. The water would continue inland, flooding areas hundreds of miles from any ocean. Now let's talk about what happens to the planet itself when it stops spinning. Earth isn't a perfect sphere. It's actually wider at the equator than at the poles because of centrifugal force from rotation. This bulge exists because the planet has been spinning for billions of years. When rotation stops, this bulge would slowly start to flatten out, but not before causing massive geological upheaval. The redistribution of this mass would trigger earthquakes unlike anything in recorded history. We're not talking about minor tremors. These would be planet-shaking events that would crack continents and reshape the surface of the Earth. The tectonic plates that normally shift gradually over millions of years would suddenly experience enormous stress. Fault lines would rupture simultaneously across the globe, creating a cascade of seismic events. Mountain ranges would crumble, new chasms would open in the Earth's crust, and volcanic activity would explode across the planet as the internal pressure found new ways to escape. But perhaps the most terrifying aspect of this scenario is what happens to our atmosphere. Right now, Earth's magnetic field protects us from deadly solar radiation, and this magnetic field is generated by the rotation of molten iron in our planet's core. When Earth stops spinning, this protective magnetic shield would begin to weaken and eventually disappear. Without this protection, solar radiation would start cooking everything on the surface. The atmosphere itself would gradually be stripped away by solar wind, just like what happened to Mars billions of years ago. Even if somehow you managed to survive the initial catastrophe, the supersonic winds, the massive tsunamis, the global earthquakes, and the volcanic eruptions, you'd face an even more hopeless situation in the aftermath. With no rotation, one side of Earth would face the sun continuously while the other side would be plunged into eternal darkness. The day side would become a scorching hell with temperatures hot enough to melt metal. The night side would become a frozen wasteland colder than the polar ice caps. This temperature difference would create weather patterns beyond imagination. Hot air from the day side would rush toward the cold night side, creating permanent, violent storms along the boundary between light and dark. These storms would be perpetual tornadoes and hurricanes that would make survival impossible in the transitional zones. The ecological collapse would be absolute and immediate. Plants need sunlight, but they also need the cycle of day and night that comes from planetary rotation. On the day side, plants would be burned to death by continuous solar exposure. On the night side, they would freeze and die from lack of sunlight. The entire food chain would collapse within weeks. Even the microorganisms in the soil that form the foundation of all terrestrial life would perish under these extreme conditions. Ocean currents, which are driven by Earth's rotation and help regulate global climate, would cease to exist. The seas would become stagnant, and marine life would face mass extinction as the delicate balance of ocean ecosystems collapsed. The Gulf Stream, which keeps Europe warm, would disappear, as would all other major oceanic currents that distribute heat and nutrients around the planet. But here's where it gets even more interesting from a physics perspective. Earth's rotation doesn't just affect the surface, it influences the planet's entire structure. The liquid outer core that generates our magnetic field rotates slightly faster than the solid mantle above it. This differential rotation is crucial for maintaining the dynamo effect that creates Earth's magnetic field. When the planet stops spinning, this delicate system would be disrupted, potentially causing the magnetic poles to flip or disappear entirely. The gravitational effects would also be significant. Objects would weigh slightly more at the equator than they do now because centrifugal force currently reduces apparent weight in these regions. While this change would be minor compared to the other catastrophes, it would still affect how water flows, how structures stand, and how the atmosphere behaves. Now, you might be wondering what could possibly cause Earth to stop spinning in the first place. In reality, this scenario is virtually impossible under normal circumstances. Earth's rotation has been slowing down gradually for billions of years due to tidal forces from the Moon, but this process takes place over geological timescales. For the planet to stop suddenly, it would require an external force so massive that it would likely destroy Earth entirely before stopping its rotation. A collision with another planet-sized object might do it, but such an impact would probably vaporize both planets. An encounter with a black hole might stop Earth's rotation through tidal forces, but again, we'd be torn apart long before the rotation ceased. Even the most powerful stellar events, like nearby supernovae or gamma-ray bursts, wouldn't be able to stop planetary rotation without simultaneously sterilizing the planet through radiation. The only somewhat plausible scenario would involve some kind of exotic physics that we don't currently understand, perhaps involving dark matter, exotic particles, or technologies far beyond our current capabilities. But even then, the energy required to stop a rotating planet would be so enormous that the process itself would likely be more destructive than the stopping. Scientists have actually studied this scenario not because they think it will happen, but because understanding extreme situations helps us better understand the systems that keep our planet habitable. These thought experiments reveal just how perfectly balanced our world really is. The rotation that seems so ordinary and invisible is actually one of the most crucial factors in making Earth a livable planet. The speed of Earth's rotation is also remarkably stable. While it does slow down very gradually and occasionally speeds up or slows down slightly due to earthquakes, volcanic eruptions, or changes in ice distribution, these variations are incredibly small. The planet acts like a massive gyroscope, resisting changes to its rotational speed through the same physics that keep a spinning top upright. This stability is one reason why life was able to evolve and thrive on our planet. The consistent day-night cycle allowed organisms to develop circadian rhythms, the stable climate patterns enabled complex ecosystems to form, and the protective magnetic field shielded developing life from harmful radiation. When you really think about it, the fact that Earth spins at exactly the right speed is almost miraculous. If it spun much faster, the increased centrifugal force would cause the planet to bulge even more at the equator, potentially causing it to break apart. If it spun much slower, we wouldn't have the strong magnetic field that protects us from solar radiation. The 24-hour day cycle is perfect for most life forms, long enough for complex biological processes, but short enough to prevent extreme temperature variations. Even small changes in rotation speed would have dramatic effects on our weather and climate. The Coriolis effect, which influences everything from hurricane formation to the direction of ocean currents, is directly related to Earth's rotation. Without it, weather patterns would be completely different, and life as we know it could never have evolved. So while the scenario of Earth suddenly stopping its rotation makes for fascinating scientific speculation, it also serves as a reminder of how fortunate we are to live on a planet with such perfect conditions. Every sunrise and sunset represents the continuation of a 4.5 billion-year-old dance that makes life possible. The next time you feel the wind blow or watch the sun move across the sky, remember that you're experiencing the effects of our planet spinning through space at incredible speed. It's a cosmic ballet that's been performing for eons, and despite its violence and power, it creates the gentle, stable environment we call home. This scenario also highlights how interconnected all of Earth's systems really are. The rotation affects the magnetic field, which affects the atmosphere, which affects the climate, which affects life itself. Change one fundamental aspect, and everything else falls apart like a house of cards. It's a sobering reminder that our planet is both incredibly resilient and remarkably fragile at the same time. Understanding these extreme scenarios isn't just about satisfying curiosity, it helps us appreciate the delicate balance that sustains life on Earth and reminds us why protecting our planet's natural systems is so important. After all, we only have one Earth, and it's spinning through space at exactly the right speed to keep us all alive.